Can you hear me? All right, excellent. Good morning. Welcome, everyone. Welcome back. So some of you are still coming in. There are still some seats in the front, if you don't find a seat in the back. All right. So my name is Peter Mika. It's my pleasure to give you an introduction to semantic search today. This is going to be a follow-up to the talks yesterday. So yesterday we heard from Tom about semantic web and some of the basic concepts in semantic web. And then we heard from Roy talking about information retrieval and web search. All right, so what I'm planning to do today is to combine these things, right? I'll probably go a bit deeper into semantic web than Tom did, and probably go higher in information retrieval than Roy did. So it's going to be a combination of the two in that sense as well. I'm going to go through essentially the process of building a semantic search engine, if you will. So we're going to talk about all the different elements that go into building a semantic search engine. Starting from data, right? So where do you find data? And once you found it, what do you do with it? How do you find data using information extraction technology? How do you collect data from the semantic web? And then how do you index this data for efficient processing? We're also going to talk about the query side. What are the different query formalisms that are out there? And again, how do you process them in order to have some kind of semantic understanding of the queries that the end users are giving you? And then I'm not going to go into much detail about ranking, but just tell you what is different or possibly different from what you already heard from Roy yesterday. And also we're going to have machine learning for information retrieval talk later from Yi Chang. So he's going to talk more about how to combine different ranking features using machine learning techniques. I will say a few words about evaluation in a particular context of semantic search. Again, there's going to be a more detailed talk on evaluation on Saturday by my colleague George Dupre from the US. And that's going to really give you a deep dive. This is really just more of an overview of what are some of the tasks that people in this community find interesting enough to be evaluated in public competitions. So these are some of the competitions that you as a student or developer can also join and test your skills against other people in the research community. And I think actually the order is flipped, but I will say a few words about the interface, the user interface, which is actually quite important in this context because we expect our users to formulate fairly complex queries. And that means that they will need a lot of help. They will need all kinds of search assistance tools, other functionality to help them make fairly complex queries. Okay, and then we'll see how we go with time. But if time allows, and I do hope it does, then I'll show you a case study. And that is a particular project that we at Yahoo Labs did in partnership with our search team to implement a related entity recommendation system. So I hope we get there because this is a very practical piece of work. And if you have questions, feel free to interrupt me in between. I'm happy to answer them, as long as I can see that you're having a question, because it's hard to see. All right, but first of all, a little bit of motivation, right? So why are we talking about semantic search? Why is this an interesting topic? Well, interesting enough, you would think that search works fairly well, and considering the investment that went into it, there would be not much to improve. But it's quite the contrary. If you talk to people in the search industry, this is a quote from actually our now boss, Marissa Mayer, but she was at Google and she made this statement. They will tell you that we are at the beginning of the search, right? There are some things that have been solved. There are particular types of queries that are working very, very well. But there are other things that are not working well, and I'm going to show you some examples. The queries that work well, let's start with that, are those queries where the user explicitly names the target of the query. The user has a particular entity, for example, in mind, and knows the name of that entity. That reference is unambiguous. There is no other entity with a similar name. And typically, the search is successful when there's a single page that provides all the necessary information. In particular, there's a single page that references all the components of the query, right? And you've already heard from Roy yesterday that since information retrieval works at the level of documents at the moment, that is fairly crucial, right? Current search engines have essentially no ways of combining information from different documents. So it's fairly important that all the pieces of the query are in the same document, or the user will have to go through multiple results, right? Which is typically the case if you have a complex query, you have a complex information need, the answer is not found in a single document, then you will be forced to essentially go through multiple documents, right? So, but some things work very well. These type of queries, navigational queries, right? So when you want to go to a website and you just type the name of the website, right? You typically get as first result the desired page, right? So if you type in, Yahoo login, you will get the login page of Yahoo. There has been a lot of investment in information retrieval. Roy mentioned, some of the techniques that go in there, basic models of retrieval, as well as combining them using machine learning. I'm not sure how much he told about this aspect, but there's also a very, very heavy investment in sort of computational aspects of search, right? So bigger hardware, right? Bigger data centers, faster network connections, right? Using memory instead of disk, or using SSD instead of traditional hard disks. These are all incredibly important investments in the sense that the faster the search engine works, the users are more satisfied in the sense that they can do more queries in the same amount of time. And they consider that as a sort of quality metric in the sense that the search engine is faster will be perceived as better. Strange as it sounds, they will find the results better simply because they can get to the good results faster by a search engine that is faster, right? But there are queries that are still hard to solve, right? And not solvable by adding more machines, right? So, some of these search engine companies, they will be very happy to invest more in hardware if that would solve some of these problems, but that's not necessarily the case, okay? So what are some of these queries? I know this slide is hard to read. I'll just call out some of the examples. So when people start talking about semantic search, the first examples that they typically give is ambiguous queries, right? So the canonical example, I think, in the IR literature is Jaguar, right? So Jaguar can be the animal, it can be the car, it can be a band, it can be many other things. This poses problems, right? So it poses problems to the techniques that Roy presented, because essentially we're counting over surface forms, right? We're counting over the number of occurrences, for example, of the word Jaguar in a document, without respect to which sense of Jaguar is present in that document, right? Paris Hilton is another example, right? So it so happens that it's both a hotel chain and a celebrity, right? Of course, the two meanings are connected in some way, but there's a fairly intricate connection there, right? Queries where there's a secondary meaning suffer in the case that you're looking for the secondary meaning, right, and not the primary meaning. The case is, George Bush, who is of course a U.S. president, but there's also a beer brewer in Arizona with the same name. Now, again, we mentioned yesterday that PageRank popularity features are very important in ranking, but they had a negative effect, and namely that they suppress the secondary meanings of terms and phrases, right? So George Bush, the beer brewer in Arizona, is very, very difficult to find because essentially all the top results that you see relates to the famous George Bush, right? And that's a problem. I would like to also say that ambiguity is not just really ambiguity in sort of the natural language sense, but also in terms of fuzziness, let's say. So there is subjectivity, right? So the user types in reliable digital camera. But really, what is reliable, right? Or Paris Hilton sexy. Now this is a common query. The user likes to see sexy pictures of Paris Hilton. But again, who tells you what is a sexy picture, right? Multimedia search is particularly difficult, right? Imprecise or overly precise searches. This is an interesting category. A lot of things fall in here, right? So in the semantic community, there's a researcher, a fairly senior, famous researcher, whose name is James Handler. He's a professor at RPI. He writes, his name sometimes as Jim Handler, sometimes as James Handler, right? Now again, we get into these counting problems, right? These two forms of his name should somehow count both for the concept of Jim Handler, right? Or James Handler, the professor, right? It's the same thing. Yet if you search, with just one of these forms, you find, one half of his papers. If you search with the other form, you find the other half of his papers, right? So that's kind of a practical problem. The other dimension by which I would say sort of difficulty increases is complexity, right? So very, very often there is missing information in the queries. In fact, that's probably most often the case. My current example is Brad Pitt Zombie, right? So there's a movie that came out in the US which features Brad Pitt, and it's about zombies. The movie is called World War Z, I believe. But of course the movie is not named in the query. It's up to the search engine to know that the connection between Brad Pitt and zombies is simply that Brad Pitt acted in a movie, and the movie is about zombies. This is very common with news. So this I observe in the query logs. So you read a news item which is about a non-famous person, right? Something happened to someone, and you forgot the name of that person, right? So you read an article about a Florida man with 115 guns. You just don't remember anymore the name of the guy, right, who had the 115 guns. So you type in Florida man with 115 guns, right? Now this is, of course, will reasonably match because probably the text mentions Florida and it mentions guns. And if you remember the number right, it will match the number in the text. If you remember the number wrong, then you're wrong. It will not match. But of course, if you knew the name of that person, right, it would be so much more easier. I can give you other examples. If you search for me, you might type in Peter Mika Barcelona. Again, the connection between myself and Barcelona may be indirect, right? I work at Yahoo, which is located in Barcelona, right? I, of course, live in Barcelona. There might be some direct connection in some kind of knowledge base that you have, but the connection might be indirect, okay? Category queries, right? So these are queries where you're not looking for a particular instance. For example, you're shopping. You don't know yet what you're going to buy, right? So you don't particularly know the name and the model of the digital camera that you will eventually buy, but you're still looking around. So you might start with something like digital cameras, right? You just type in that query. Barcelona nightlife, right? So you're searching for things to do in Barcelona. You don't exactly know what is it that is interesting in the nightlife of Barcelona. Bars, clubs, whatever. You don't really care at that point. You just want to be entertained. And then there are really complex needs that require some kind of computation or some more advanced processing. You probably have seen that search engines, for example, have calculators built in, or they have currency converters built in, right? So you can type in, $120 in euros, right? This will be solved, but it's solved in a very specific way, right? There's a particular application that just was designed to do this currency conversion for you. which gets triggered for these particular types of queries. But this is not a generic solution for doing computation in a search engine. Digital camera under $300, right? This is another category query where you already added the restriction, right? I'm not just interested in reliable, cheap, blah, blah, digital cameras, but it has to be under $300. So now I really want to restrict on a particular attribute of the cameras. And one thing that actually we worked on in Barcelona, which is even more sophisticated, if you will, is doing some kind of prediction, right? Now you might think that it's crazy. How do you do prediction on the web? Well, for example, the query world temperature in 2020 or climate change in 2015 or 50, whatever. Well, what you do is you essentially try to understand that certain documents have references to future dates, and you try to relate that to the query. And then if you want to go even further, you might want to aggregate the predictions of what climatologists say about the future temperature of the planet at a certain point in time in the future. But you might understand that this is a very, very complex query. Right? This is a complex analytical query. Summarize me the opinions of all the climatologists out there and what they write on the web about what the climate will be in a certain given date in the future. Right? This is very sophisticated stuff. Right? All right. This is a note to myself as well that some of these queries are so difficult that users have learned not to type them, right? This is an important point because we have been already using search engines for 15 years. We have learned what works and what doesn't work. So some of these things you will not even find in the query logs, right? So that's a problem in the sense that if we're able to solve these queries, we have to teach our users that now we're able to solve them, and now they should be asking these queries. Right? There's a learning effect, right? So we certainly know, for example, we did studies at Yahoo that if you start recognizing certain patterns, right, you add this currency converter, you trigger it in certain ways, right? So certain keywords like dollars in euros, that triggers the currency converter, right? After a while, people learn it, so they know how to recall that tool, right? If they type in the right pattern of keywords to recall that particular tool. So we're very tuned to, even subconsciously, learning how to search, right? But it takes some time, right, to relearn things. All right, so here's an example using our favorite colleague, Roy Blanco, right? So you're searching for Roy Blanco in Yahoo search in this case. The results are fairly good. They all relate to our favorite Roy, right? It's his homepage, his LinkedIn, his Facebook, his ACM, his DBLP. I would say this is a perfect set of search results, right? The problem is, this is Roy, right? Just to remind you, I don't know if he was wearing glasses yesterday or not. Of course, the problem with the advertisements is that they might not relate to the same meaning. Right? So these are sinks, right? If you look at the text, these are cheap Blanco sinks. Apparently, Blanco is a brand of sinks as well. I believe Roy has nothing to do with this brand. He makes no profit on this query. If you click there, there are also holidays to Rio de Janeiro. Now you notice that we have actually rewritten the query. So there's some linguistic processing going on here. We figured that Rio and Roy are really just one at distance, one swap, right? So why not do that? We can surface some advertisements. Right? So Rio de Janeiro, right? Interesting place to visit. And there's also a brand of cars, the Kia Rio, right? So now we have at least 4 different interpretations of the same query on one page. Is this good? No, not so much. So trying to avoid this, right? This is a bad example, bad example. I would like to point out that searching over advertisements is difficult, and it's made difficult because There's a sparsity, so there is certainly much less text to the advertisement itself. There are much less advertisements to choose from on the first place. So it is a search engine that has a somewhat more difficult problem than the web search engine in terms of the corpus. And also, it doesn't have links, right? It doesn't have some of the features that the web search engine has. And also, it has to take monetization into account, right? So it has to do some complex balancing between showing relevant results, as well as trying to make money, right? Because this is what is paying for the free service that is called web search. So a very, very difficult problem, searching over advertisements. Though we're not talking about it at this summer school, there's an entire field called computational advertising, which deals with this problem. Right? All right. The second part of the motivation of why we're talking about semantic search, and you got this hopefully from Tom yesterday, is that this thing called the semantic web is now becoming a reality. We've been talking about it for a very long time, right? So first conference is in semantic web, probably started around 2001, but Tim Berners-Lee has been talking about this since the beginning of the web, right? So essentially in 94, in his book, 96, I think the book is from, I believe, Weaving the Web, the title of the book. He has a chapter on the semantic web, right? And already 96, 97, standardization started at the W3C, right? The standards organization for the web. So we've been talking about it for quite a while, and W3C has been churning out, specification after specification to build this technology stack, right? That would enable the semantic web. There has been a gradual progress also in tools. So I'm going to mention some tools today. There are multiple free and commercial tools for all kinds of tasks related to manipulating RDF data. I'll mention some of them. And in terms of data, again, I'll show you examples, but we've made quite a bit of progress. People publishing data on the web, using sort of the open link data ethos that Tom talked about, right? So there's really much more than just technology there. There's really a community that feels very strongly, very passionately about putting data online, right? So government data, for example, right? The examples that Tom has shown, right? Enabling people to make government efficient by analyzing government data, right? Finding inefficiencies, finding outright fraud, right? In some cases, right? So in some cases, there are examples where people have found fraud by detecting suspicious things in government data that's been eventually released publicly, right? So there's a large interest in this, and we'll talk about sort of the investment in web search companies as well as Facebook. Not a traditional web search company. Though Facebook does have a fairly large crawl of the web at this point, and sort of building private data sets, building their private entity graphs, knowledge bases, whatever you want to call them. So there is commercial interest, which is good. There's commercial interest also because there are end users, right? So it goes in that direction. And end users are not trained in the logical formalisms of the semantic web, knowledge representation frameworks, right? They cannot learn complex query formalisms like Sparkle, right? So even if you think of SQL, it's not something that an end user would type into a search engine, right? It's something that a developer or a database administrator would type in to a SQL database, right? So the same is true here. These are not end user query languages. We don't expect users to type in Sparkle queries into a search engine, okay? And an equally big problem is that if you have data, and if you have graph-shaped data or you have relational data that an end user needs to search over, that end user may not know anything about the data. In particular, he or she may not know how the data is structured, what are the names of the columns, what are names of the labels on the edges of the graph, what are the types in the vocabulary. And in that case, again, we cannot expect the user to precisely formulate a formal query or structured query because he or she does not know the right name to refer to things. And they may not even be experts, right? So let's say they are searching for a product, but they're not the experts on that product, right? They just want to buy a digital camera. They don't really know how digital camera works. They don't know what are the important attributes, what are their names, right? These kind of problems. All right, and this is a reminder to me that commercial interest and having a business model is kind of important, right? This is a scene from South Park, right? The episode where they decide that they will do a business. And they know that what they like is to collect underpants. So in the first phase, they're definitely going to collect underpants. And they know that they want to have profit, right? So that's going to be the third phase. They only haven't figured out what's in the middle, right? And this is kind of where the semantic web was like 5 years ago, right? We knew we like to build this linked open data web, and it's all going to be beautiful, and we're all going to be dancing around, singing beautiful songs. And we knew someone will have to pay the bills at the end, right? So we knew someone will have to pay for this, right? We didn't know what's in the middle, right? That's a bit of a problem. If you ever encounter yourself, working on a project or working in a research field which faces that dilemma, I think that's a real dilemma because eventually whatever you do will have to be useful to someone out there, right? To keep the lights on, let's say. Okay. But that's all I'm going to say about making money. So that's the good news. All right. So what are these? Just some of the teasers, right? Of what are some of the things that people have been building using semantic search technology. Well, if you look at entity queries, one thing that you will see is entity disambiguation functionality. So we mentioned the problem of ambiguity. This is one of the solutions to it. So here the query is Taj Mahal. The search engine is Google. And Google offers you to choose between Taj Mahal, which is the famous Taj Mahal, I hope, or maybe not. Let's see. No, it's a musician. All right. So it's not the famous Taj Mahal. It's a musician. And hopefully there's somewhere down there's the famous Taj Mahal. There's also a casino, right? So you see the different interpretations. Oh, I see. So the famous Taj Mahal is right up there, and these are the alternatives, right? So apparently there's a musician as well as a casino located in Burbank, Atlantic City. All right, it's located in multiple places. So you can choose all the different interpretations. If you're not thinking of the famous Taj Mahal, then you're thinking of one of the alternatives. Being something very similar going on. Entity search, if you type in the name of an entity, this is Google, you see some kind of an information box. So this is very similar to what you would get in Wikipedia, right? So kind of encyclopedic information, right? So things that you would generally want to know about this entity, in this case Mercury, like when she was born, when she died, what she did, and so on. All right, something very similar being going on. You might want to also navigate to related entities. Search engine is Yahoo here. The query is Brad Pitt, and here, is there a pointer in here? I don't know. Is there? Up? Down? I don't know how to push this. All right. All right. So you see the related people here at the bottom right corner on this slide. In this case, Angelina Jolie, Edward Norton, Jennifer Aniston, George Clooney. All right, another example with a location query. The location is Paris, and you see here related points of interest. These are things that you might want to visit in Paris. Right? Factual search. So we're talking about having explicit information needs. In this case, you're looking for the wealth of Bill Gates.